Okay, today we're going to be going over adding and subtracting rational expressions. Just to save time in the video, any polynomial factoring that I'll have to do, I will be skipping over the box, going straight to the factors. Anyways, in order to add or subtract rational expressions, we need a common denominator. So, if you notice in example 1 here, we already have the common denominator of x plus 3. Once you have your common denominator, just write it as one fraction with the common denominator on the bottom. So 2x plus 5. The plus came from here. Once you have it written as one fraction, you try to simplify. Notice I can't combine like terms on top, so I can't simplify. And then see if you can factor to cancel. And I can't factor to cancel either. So this is the answer. Second one. Well, now I can see the denominators are not the same. So in order to find a common denominator, what we're going to do is we're going to factor the bottoms of both fractions. The first one, x minus 2, is already factored. X squared minus 4 factors into x plus 2, x minus 2. So now, when I go to find my common denominator, I'm going to need everything that appears. So I see an x plus 2 in the bottom of at least one fraction, as well as an x minus 2 in the bottom of at least one fraction. So I need x plus 2 and x minus 2 for each fraction for our common denominator. My tops are originally -8 and x. But I can't just add things to the bottom of fractions all willy-nilly like, so I have to balance it out. The first fraction goes from having x minus 2 to having x plus 2, x minus 2. I need to tag on the x plus 2 part. The second fraction went from having x plus 2, x minus 2 to having x plus 2, x minus 2. So I don't need anything on the top of that one. Now that I have a common denominator, I will write it as one fraction. So I have x plus 2. I guess I'll just put it as minus 8. Next, if possible, simplify the top, and this time I can simplify the top. I'll distribute x through, giving me x squared plus 2x minus 8 over x plus 2, x minus 2. And just a reminder, I can't cancel out the x plus 2's here because it's connected by addition or subtraction on top. Now there's one thing that remains before I say I'm done. I have to try to factor and see if I can cancel anything with this problem. If I factor, let's see, I believe I get x plus 4. The top does actually factor this time. And x minus 2 as the factors, which means x minus 2's will cancel out, leaving the final answer to be x plus 4 over x plus 2. And that's it. The next one. So again, we're going to simplify, and again we need a common denominator. This time I can't factor either of the bottoms of the fractions. For my common denominator, it's going to require both pieces that I see, both the 3x minus 1 and the 2x plus 5. 3x minus 1 and 2x plus 5. For the top originally has a 6x and a 4x. And again, I can't add stuff to the bottom of a fraction all willy-nilly like, so I'm going to have to balance it out. The first fraction, to balance it out, I have to add the 2x plus 5. In the second fraction, I have to tag on, I should avoid using the word add, but I have to tag on the 3x minus 1. Now that we have it balanced out, we're going to write it as one fraction. 6x times 2x plus 5 minus 4x times 3x minus 1 over my common denominator of 3x minus 1, 2x plus 5. Just like I mentioned with the previous problem, I can't cancel out the 2x plus 5 because the subtraction sign. Similarly with the 3x minus 1. So instead I will simplify. So I'm going to distribute through. Give me 12x squared plus 30x minus 12x squared plus 4x all over my common denominator of 3x minus 1 and 2x plus 5. Combine like terms on top. The 12x squareds cancel out. Give me 34x over 3x minus 1 and 2x plus 5. And that's it. Okay, the next one here will require us to find a common denominator. However, there's monomials in the bottom of the fraction, which means how I proceed in getting the denominator is slightly different. So for the denominator, since I can't factor the bottoms, what I'm just going to look at is the common multiples. So just like before, as far as the 2 and the 3 goes, the common multiple, or the least common multiple, is 6. For the variables, I want to take the variable with the highest power. And that's how you find the common multiple, or the common denominator, when there's monomials in the bottom of the fractions. Just take the least common multiple of the two numbers, and then take the highest power of each variable that you see. Anyways, from there, we continue to go through the process. Just like before, we have to balance stuff out. So what do you multiply 2x to the 4th by to get to 6x to the 4th? We just have to multiply by 3. To go from 2x squared to 6x to the 4th, from 3x squared to 6x to the 4th, we have to multiply by 2x squared. I just like to put that in front because it's a monomial. Next, I'll write it as one fraction, just like I have been. And I'm actually going to do this multiplication here this time. 18 minus 2x squared times x minus 3 over 6x to the 4th. If I continue to simplify the top, I'll have to distribute. So 18 minus 2x to the 3rd minus 6x squared over 6x to the 4th. Let's see. Now I should try to factor, since I can't combine like terms. I think I can factor 2 out of everything. I can factor 2 out of everything on top. So that would become 9 minus x to the 3rd minus 3x squared over 6x to the 4th. And the 6 and the 2 can reduce. And that's about all I can actually do for this problem. So the final answer would be 9 minus x to the 3rd minus 3x squared over 3x to the 4th. That's it. Okay, the next one. Example 5. Simplify, and we're going to use 2 different methods. So the first method is the one that I'll do in class. In order to actually do this one, there's the division. But before we can do division, if we follow the order of operations, we have to take care of the adding and subtraction, adding the 2 fractions in the top, because it's like they're in a kind of a imaginary set of parentheses. So before I can do keep, change, flip and start simplifying through division, I have to make the top part just a single fraction. In order to do that, I need a common denominator. Common denominator in this case will simply be x plus 1 and x minus 1. So just like before, I'm going to give myself the 2 blank fraction bars. I want to make sure I'm kind of color coding stuff. I'll just carry everything else over. And we can't just add stuff to the bottom of a fraction all willy-nilly like. So the first fraction, the new piece on the bottom, the first fraction on top there is x minus 1. And for the second fraction, it looks to be the x plus 1. Now that I have that, I'm going to write it as one fraction. So one fraction on top, I mean. So we have x minus 1 plus x plus 1 over x plus 1, x minus 1, and that's all over x over x plus 1. Now, I can't cancel out anything yet, but I am going to combine stuff on top. Since there's a plus sign in the middle, I can ignore the parentheses and just combine like terms. Negative 1 and positive 1 will cancel out, leaving me with on top x plus x is 2x over x plus 1, x minus 1, and all that's over, let's see, over the x and the x plus 1. Now that the top is just a single fraction, I can do keep, change, flip. So 2x over x plus 1, x minus 1, change the multiplication and flip the second fraction. Now that it's a multiplication problem, we should factor everything, but lucky for us, it's already all factored. So I'm just going to cancel anything that appears on top and also on the bottom. I see an x plus 1 on top and also on the bottom. And I see an x on top that's also on the bottom. My final answer is whatever's left. 2 over x minus 1. Okay, and the last method, which is a very easy, probably actually makes the problem easier, but it's not similar to something you've done before, so it can be confusing. But for method 2, you again start by finding the common multiple of the bottoms of these fractions. And technically, I can include this one as well. The common multiple between the three of them is x plus 1, x minus 1. So what I'm going to do is I'm going to multiply the top and the bottom of each of the whole thing by x plus 1 and x minus 1. Essentially, I'm multiplying this expression by 1. I'm multiplying by the common denominators of all the complex fractions here. And there's a nice thing that happens when we do this. If I go and distribute this through, so this is all one term, so distributing it through would give me x plus 1, x minus 1 over x plus 1, plus distributing it through here gives me x plus 1, x minus 1 over x minus 1. And on the bottom, when I do the multiplication, gives me x plus 1, x minus 1 over x plus 1. And if you look, all these fractions have some things that cancel out. And I go straight to having x minus 1 plus x plus 1 over x times x minus 1. Now, normally when I do this by hand, I actually skip this whole middle step. I know that when I distribute, things are going to cancel, so I don't worry about writing this huge fraction here, or this one. I just automatically cancel out the things that cancel and leave what remains. So I go straight from that first step to here. But it helps to see it written out. Anyways, once I'm at this point, I just simplify the top, and then see if anything will cancel here. Ignore the parentheses again because there's a plus sign, so negative and positive cancel out, leaving me with 2x over x minus 1. Oops, I wrote plus 1, x minus 1, there we go. And just like the previous version, x's cancel out. Then we with 2 over x minus 1, which should be the same thing I got in the previous problem. There we go.